So this week we decided to focus on what is time? Time's a huge concept. We feel its passage like when you start working and you're working, and then the next thing you know, it's lunchtime. You've just felt the passage of time. It's the only way that we know time exists, and we've given it a name, but we really don't know what time exactly is, although we know that it affects everything around us. And actually, they think time might be an energy, and if you remember your subatomic particles, one of them was called a tachyon. And that one is still a hypothesis. We don't know if it exists. The same way we don't know that a graviton exists, even though we feel the effects of gravity all the time. Time comes up a lot, doesn't it? So we've all agreed as a society all around the earth that we're going to break time down into 24 hours. But why? Why 24? Where does that come from? Interesting fact is, it only comes from the nighttime. So many years ago, about 5,000 years ago, actually more than 5,000 years ago, there was this amazing ancient civilization called the Babylonians. And they loved the sky. They couldn't get enough of the sky. They would watch it for days and days and years to see what was going on. And they would sit out and they would study the stars, and they noticed that clusters of stars kind of made shapes. Sort of like if you're laying out in a field and you're watching the clouds and you'll see bunny rabbits and dragons and horses in the sky. They did the same thing with the stars. And they would lay down and they were like, oh, that constellation. And as they were hanging out in the field, just looking up at the beautiful sky overnight, they started noticing that there was a really bright star that was always right in the center. And they started to realize that all those constellations that they had been finding and all those groups of stars were rotating around that star. And they started to notice that, and they were just paying attention, and that star was called the North Star. That's what we call it today. And if you go out and you look for the brightest star in the sky, that's going to be the North Star. And they also noticed another interesting thing that was happening. All those constellations that they had been watching, they noticed that they would rise in the east and set in the west, very similar to the way the sun does. And they were like, whoa. And they also started to notice that they could pick certain constellations and they would rise at a certain moment every single night, and they would set at a different moment on the night as well. So they started to watch this and realize that they were evenly separated, much like you would if you were sharing a pizza. You have a big round pizza and you want to cut it into slices so everybody gets an equal slice. They realized that if they were rising and setting on a schedule, like it was all timed and it was perfect, and they used that to start calling them hours. So when a particular constellation was rising up, it was that constellation's hour. When the next one would rise, it was that constellation's hour. And there were 12 of these that they could track that were all even. So it gave us the 12 hours of the night. And since the night and the day are the same, they just use those 12 hours to keep track during the day, because during the day you can't see the stars. The sun's out, it's too bright, you can't see past its light to see the stars in the sky. Now, the Babylonians were very smart. And remember, this is over 5,000 years ago. So they looked up at the sky and they saw the sky spinning around the star, but they knew better, because what they did know is that it's not the sky spinning around, it's us spinning around. The Earth, it spins constantly in space. It's always spinning, constantly spinning. And what is it spinning on? An axis. So there's a straight line that goes down the center of our Earth. It's not a real straight line. It's not like a big pole that's stuck in the Earth that's spinning it around. But we think of it as a center line that this spin is on, because if it doesn't spin on its axis, we're just wobbling everywhere. It's going to knock everything off and it's going to go careening crazy. But we're lucky because we have a nice, stable spin that occurs, and it just keeps spinning and spinning and spinning. And the sky stays in the same place. It never moves. So we're spinning and we're seeing the sky, and we're seeing it rise in the east and set in the west. And they were using that to break down how time was working. But this runs into that same problem we talked about earlier. You can see the stars at night. You know, it might be cloudy sometimes, but usually you can see the stars. How do you track it during the day? Babylonians were very clever with that as well. They came up with a really cool idea. They're like, We can see the stars at night, but when the sun comes up, what do we use then? Shadows. They realized that during the day, as they were walking around, their shadows would change position. They would even change size and become longer and shorter. Now, what is a shadow? Shadow uses light energy, kind of. It actually blocks light energy. So we were talking about our types of energy, we were talking about photons. This is a light bulb, much like the sun at the center of our solar system. It's a huge light bulb that's just constantly casting light in all directions. It's radiating that light out. Well, as it's radiating the light towards the Earth, it might hit something. And when it hits something, it stops that light from going through. So something thick and heavy, the light will stop. But the other light around it will keep going. So when it hits our piece of paper, we'll see this object as a shadow. So the shadow here is where the light, the photons can't pass by that like item that's in front, and then it casts, as they say, a shadow on what it's using. So they use that idea of a shadow to make something called a shadow clock. And that's what we're going to be doing this week. We're going to be making a shadow clock. So some of the items you're going to need for the shadow clock, which is also known as a sundial. We call them sundials, but they're actually originally called shadow clocks because they're tracking the shadow. You're going to need a paper plate, a stick of some sort, a marker, tape glue, or Play-Doh. Just putting up something to hold a stick up, and you'll see how to do that. So the reason we're doing this is because something really cool is about to happen this weekend, I believe, which is why we're doing our time studies today. So, happens twice a year. It's called daylight savings time. It's when we agreed to change those times. So what our shadow clock is going to do is we're going to set it, we're going to see what times it shows, and then after daylight savings time, we're going to see a change occur. So we're going to still get up at the same time we normally do, but our shadow clock is going to see a different time because it's going to see the time it was before we decided to alter it. So let's go over and make our shadow clock. Okay, so this is the project where we're going to work on a shadow clock. I have a variety of things here, of which I'll only be using a few, but you could use glue, some Play-Doh, some tape, the Sharpie, which everyone should have, a paper plate or another sort of surface that you could use that's large enough for you to write on, and now the choice of stick. You could use a pointy pencil, you could use a stick, you could use a skewer, you could use a chopstick, not to be confused with a stick because it's a chopstick. Usually comes in a pair, but right now we only have one, so it's not chopsticks, it's chopstick. Still, don't confuse it with a stick. All right, so during this project, we want to be able to track what time it is, but it's just a paper plate. It's not a clock, right? We're gonna make it into a clock. So I'm gonna use Play-Doh. Thank you, Miss Kim, for providing that. And I'm going to take this and I put a hole in the center of my plate so that my chopstick here can go into it like that. And then, actually, I'm going to put it in this side. And then I'm going to put the Play-Doh around it to hold it in place. Stay in place, please. There we go. You could also use glue to hold it in place, which is nice. And then I'm gonna go outside. Now I'm gonna try to make sure this is a time that I know that I can go outside. So if I'm at home, hopefully it's in the afternoon, and make sure it's on a sunny day because we have a lot of these overcast days happening and you don't get much sun, so you don't get a good line. But I've got a lamp here today, so I can actually make a really strong line. The important thing is that you do not want this stick to move in relation to your plate. And I'm gonna take this, and I'm just gonna draw a line. As you can see how dark this shadow is, I'm gonna draw a line there on that shadow, and then I'm gonna check the time. What time is it? 2. And it's about 3 o'clock. The easiest thing to do is to keep the time on an hour if you can. So I'm gonna say that's 3 o'clock, and it's right in line with our artificial sun that we're using here. Now I'm gonna remember where I put this. So if you're at home and it's in a driveway, we're gonna have it in a driveway. If it's at school and it's outside, we're gonna make sure it's always around the same place outside, and that when the sun is in the sky, it can cast a shadow. Now, hopefully, you'll be able to, in one more week after daylight savings time, when you put this down, see if it's in the same spot. And you can check this multiple times in a day. So say you come out at 2 o'clock and the shadow's cast here. You could draw a line and say 2 o'clock. Well, or you can actually try to track every single hour you're at home. So if you get home at 4 o'clock, you can track 4 o'clock, 5 o'clock, 6 o'clock, and you can make your entire sundial all the way around track the hours of the day. It can get really involved. You could break that down into half hours as well. But have fun with this and tell me what it's like after daylight savings time. Tell me if you're still in the same hours. All right, bye.